Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson, and we were talking about a scenario that one of our listeners pointed out to us where he experiences intermittent failures during tests, and how do we analyze them? And
the
technical answer is with some difficulty.
Yeah, it is. I thought about it a little bit before I sent back an answer, and I thought, I got to talk to Chris about this one because he loves these juicy questions like this. But it was from John, Jon, and he said, "How do you analyze intermittent failures events during a test?" And I was like, "Huh? Okay." And my first answer was, it depends. What do you call a failure? But then he said, say I have a widget, it does a function, and it's supposed to survive 30,000 cycles on a test, at which point testing is suspended, and we do a more detailed check of the functionality. And there are several samples on the test at the same time. Okay, all right. I didn't get into what this test was or what they're trying to do, or he didn't give a lot of details about product or anything like that. Say one sample passes the functionality test at 30,000 cycles, but we know that a couple of times during the test, precise cycles are known, it failed to perform, but resumed functionality on the next cycle. It was not removed from the test at the time of the events. Can I develop a widget reliability model under these circumstances? Worst case, I take the first glitch as the failure point, which he did. But it seems like there should be an inherent reliability information in passing cycles beyond. And then it was, I have access to these software packages. And I was, well, before you jump into the software package, let's think this through a little bit. So what are your first thoughts there, Chris?
Two parts to it is when he said he's trying to analyze these, I first thought he was saying he's referring to root cause analysis. We're trying to find out why that was happening, but it felt like the question then meandered to a different sort of analysis where you're trying to characterize it using statistics. Mm-hmm. Either's possible. If you've got intermittent failures, essentially there's no physical signature left behind. So root cause analysis then needs to involve this wonderful thing called your brain.
Or really good sensors that catch the failure in action.
Yeah, in which case a lot of the gnashing of teeth goes away if you have that sort of forensic record of what actually happened.
Oh, I don't ever want to recommend somebody go get logs from some software system that's tracking all this stuff. You ever have a computer crash? You ever actually try to read that thing? I don't wish that on anyone. But yeah, I digress.
Right. So I take your point that I'm having a few issues with computers myself these days, and then the logs are, interesting.
Yeah. Let's leave it at that. It's a family show.
That's right. But so that's from the root cause analysis perspective. You have to use your brain. You have to work out, okay, what could have caused this? And that's why root cause analysis has to be done. When it's done, it has to be done well. It's about facilitation. It's about brainstorming, cross-functional teams and the rest. There's a reason why we bang on about that during root cause analysis courses and discussions. Mm-hmm. If you're not taking it seriously, you're not taking it seriously. It's as simple as that.
Well, I back up one step there, Chris. Is that intermittent, if it fails for one cycle, and I don't know anything about the details of the cycle, maybe I don't, but would the customer call that a failure if it failed over one cycle? Or is that, and it came back on the next cycle, and that's okay, I can deal with that. If something resets, I have painful memories of my old computers from the 286 and 386 days of Intel chips, when the most common scenario of fixing a problem on your computer was reboot it. And you just rebooted it in the morning just so you could get to lunch kind of thing. And it's like, if that loss of 20 minutes is acceptable to the customer, then it's and they don't call it a failure. They're perfectly fine with that. They don't lose any data. They don't lose any transactions. They don't lose any sleep over it. Then it's not a failure. It's still working. And instead of 30,000 cycles, you only had 29,000 or 29,999 if it had that intermittent failure or event once. It's, to me, it's what do you define a failure? If that's not a failure, then don't count it. If it is a failure, then you have to count it. But it's not us to decide, it's the customer.
But that said, I mean, if your thing is doing something and you don't get why, I'll be reticent to say everything is cool.
If the customer doesn't care. Yeah, that's true. Yeah, it could be causing all kinds of problems and you're not paying attention to what's going on.
Right. But if you have that perceived failure, even if it's like intermittent, and you say, well, in the customer, let's hit the button again. If it works the next time, the customer may be just as happy. You go, that's cool. Understand that. However, if you don't know why it missed in the first place, you might be missing a really important understanding of your system, which might deteriorate rapidly later on. And you'd be kicking yourself later on for not investigating when it first came up in your laboratory. Does that sound familiar to lots of other scenarios you've been posted?
Oh yeah, run into lots of times. Yeah.
Yeah. So even if I'd be very nervous to just discount it because of just simply coming down to the fact it's I don't know. I'd be beyond nervous. So that's one thing. But I want to do an RCA on what that's happening before I sort of call the customer would be happy card on it. That'd be a fair call.
Yeah, no, I agree. Once even with the first glitch, I mean, I've run plenty of tests where like one of the sensor wires fell off, kind of thing. Well, that's a function of my test. The product didn't do it. It was my test setup wasn't good. But I understand it. Oh, that wire came loose. All right, let me reattach it. Now it works again.
Nothing to see. That's one of the best RCA outcomes you'll ever have. The thing's not working. You go in there and realize the sensor cable came off. You go, oh,
yeah, it's my fault.
That's what confidence looks like. Yeah. But that's cool. That's what you want to find,
Well, the alternative is that, well, it's a prototype. So we don't count any failures on prototypes. Then why are we testing this?
Yep.
You only count it if it passes. Is that what you're saying? Oh yeah. We don't like failures.
We're a success-oriented organization.
That's a whole different problem. But yeah, first off is what's happening, what's triggering that intermittent type behavior. And that inherently is difficult. If you do 30,000 cycles and it intermittently, it's no warning or no buildup, no pattern to it. Those are notoriously difficult to troubleshoot and find and sort out and stuff. And that takes some real thought to figure out what's going on. You got to get it to the point where you can replicate it. Say, if I do this, this, and this, then it happens. Right? And you got something there. You can go try to figure out more details going. Unfortunately, most systems these days, it involves reading through notoriously poorly written logs that it's a needle in the haystack sometimes to sort it out. But that's where the team comes in.
But your first go at RCA might not get to that level. But if you do your RCA and you find, likely, or say 5 potential reasons that happen, that's when you can get clever and start putting sensors on the test to look for telltales indicators of any one of those in particular, to help you in the future work out what's going on. I mean, that's something which has happened a lot with clients I've worked with, where they say, well, the RCA couldn't find anything. We knew it was down to 5, but then we walked away from the discussion. Go, what? Why? Why did you walk away? You actually did some really good things. You realized it was one of these 5 likely scenarios.
And then how do you go check them? Yeah, 3 of them you can actually check and eliminate or confirm that it's related to this problem.
But it's like that. It's like a scenario where, well, we couldn't come up with an answer before the conference room was allocated to somebody else. That's not what we're about here. But that's the RCA piece. But I think your friend John's talking about statistics more than anything else.
Yeah, and then that's where I went with 2 answers. One, if I branched my first question, I said, if it's not a failure. It's not something anybody cares about. Even if you understood it and fixed it wouldn't go anywhere. You wouldn't change anything. Then use the standard time to failure data analysis to the end. You went 30,000 cycles and you had a couple of samples and whatever pattern of distribution you were using, assuming was happening, and that gave you some confidence that you're at least some reliability on a success test kind of thing. It's the way I'm reading between the lines that's what we're doing. But if it's the intermittent thing is important, then it's recurrent failure. It's repairing itself, or something's happening to reset or repair or get the system working again. It's just a really fast mechanic that's inside your system realigning the electrons so that it works again. The repair time is just reboot, and it doesn't sound like it's a long time for that to happen. But now that's recurrent data. You have time to failure and another time to failure and another time to failure, and the repair times are relatively small compared to the time it's operating. And that's a different kind of statistics than doing log normal or Weibull or stuff like that.
Yeah, so it's sort of like the on-demand failure, which you combine with your other sort of more traditional reliability curve-like analysis. You certainly can't discount it.
Well, that's true. That's where I jumped ahead, and I agree that you need to understand it. But I also know it's really difficult in many, many circumstances to sort out intermittence. So I went back one other step. Does it matter? Do we care? Now, it may well, I agree with you, Chris, come back to bite you. This was an indicator for a much more serious problem that's going to plague you and your customers going forward. So do spend the time to understand it the best you can. When it comes to just the set of data, and say your task as the statistician on that group, and it sounded like John analyzed it both ways. He says, well, I'm going to take it to first time to failure, or he did it two ways. One is I would do the first time to failure and do a fit for that or some analysis for that. I don't know how you do it unless you had more than two samples. But the other one is I'll ignore them and I'll just say they all made it to 30,000 or some number close to that. And that's a different analysis to say what the resulting behavior is. The other piece I mentioned is that if both of those analysis, worst case, it's time to first event, and the other case is that we ignore them and it goes all the way in. If it doesn't change the decision of whether you launch this product or not, or if it meets the criteria or whatever, why you were running this test, if it doesn't change the answer, then it doesn't matter. It might be that you're going to ship it anyway, but then don't waste your time, kind of thing. But if you're going to do recurrent data, it's slightly different than just time to first failure. And I think that understanding the mean cumulative function plot may get you some insights of what's going on. Is this, especially if it shows that the events are occurring more often as the longer the cycles run, then you got something that's getting worse with time. But if it's getting better with time, maybe it's an early wear-in type phenomena where the electrons are warming up stuff and they're getting better at doing what they're doing, and then it doesn't have the glitch. Maybe it's a timing issue that the copper needs to settle in before it's useful. There's all kinds of phenomena. I have no idea what the product is, but it's a different analysis when you're looking at failures that get repaired and then put back in service, and you're interested in the long-term behavior of that system.
Right. I suppose the key message is you just can't discount them. You can't just wish them away.
Well, it's so easy. Wave of the arm, just poof. We can assume those aren't important. And it's no problem. Yeah, I'm being very facetious there, by the way.
Yeah. But if you're testing them, you certainly cannot discount them. There's a reason why you're testing. But yeah, I think there's a few challenges involved, but
that's where we get paid the big bucks.
Right. But you can either, people get focused, I would argue, too much on whether this is a quantitative test versus a qualitative test. That is, are we testing to try and measure reliability or improve reliability? And I'd argue that even if you have a measuring reliability test, you're just trying to characterize the reliability of something, which, there's a time and place of that, but you uncover as part of it an opportunity to investigate a root cause of failure or a failure mechanism. You go for it.
Yeah, you really should. The I had one other thought of this. Is one of the things in John's message is that they were monitoring the functionality per cycle, some sort. So let's imagine that it was, say, a built-in self-test that was running a loop inside some electronics box of some sort, and that constituted a cycle, and then it was powered off and powered back on and reset some way, and there was another cycle. I have no idea. I'm just making that up. But I know from experience that the built-in self-test or running a functional diagnostic on an electronics box can range from, oh, the green light came on, so it's working, kind of thing. It's got power, to which is testing really only the power supply, that it's functional, or it's running some algorithms to test all these circuits are still the circuits we think they are, and they're doing what they're supposed to do. They're showing 5 volts, or they're showing 0 volts at the appropriate times. They're in the binaries are happening like they should, or it's reading and writing something and passing data through a system, or it's reading, doing an analog to digital conversion of some sensor or whatever it is. We tend to run functional tests to see if it's functioning, independent of whether it's failing. And the measurements, I'm thinking of like a motor in a factory. It may be spinning and turning that fan and doing what it's supposed to do, but it's making a horrible noise, and we can see the bearing is just kind of rattling along in there, not actually attached to anything anymore. And it doesn't take much to understand that even though it's blowing air, this fan is working, that it's failed. It is functionally working, but it's going to just destroy itself and all kinds of other stuff here shortly. It depends on what you measure in the testing. So if you're measuring the temperature and the temperature rises, or the current draw and the current draw is going up, or whatever your indicators for a healthy device is, that's different than did the green light come on?
Right. And it's not just, I keep going back to, you really want to make sure you know what's going on. Yeah. What was the scenario I was talking to you about recently? I think it was LED lights. Mm-hmm. How they advertise as essentially they last 1,000 years. You never need to replace them, but we know
they tested 1,000 of them for a year.
Yeah, but all you do is you can see, okay, and when people who know where those numbers come from, they scratch the surface. They come from the advertised fit rates that the manufacturers come up with, and those fit rates are incredibly small, incredibly low, which is essentially a failure rate. But that's sort of like the failure rate associated with their diodes before they actually accumulate any damage. Mm-hmm. And so you have this fictitious scenario where I actually, at the time, I had a look, and average, you might even do that right now while I'm talking to you. I don't know if it's kosher for podcasts to involve Googling as we go, but it's like trying to calculate the human life expectancy based on how often a healthy 25-year-old male dies.
Oh, pick 10-year-old, because then we'd be immortal. The data shows that 10-year-olds are well nigh immortal. They have the lowest, if they make their 10th birthday, they're better off to make their 11th birthday than any other age that we're ever in. 10-year-olds are just resilient. Go. They're amazing.
Well, there we go. According to Swedish males, I think not the 10-year-old, 15-year-old males seem to be very
before driving,
the lowest mortality rate.
Yeah. So if we study a couple thousand 15-year-olds and then we say, oh, that applies to all humans, then we're like, we're kind of cherry picking here, guys.
Hmm. And again, if you do the math, which I'm furiously trying to do to make the point right now, here we go. So if you look at Swedish males and you say, let's just get a bunch of 15-year-old Swedish males, we'll test them, so to speak.
How many make it to 16?
Becomes some, and just see how many of those human 15-year-old males die in that 1 year period. Okay, so on average, we get you'd find that the chart I'm looking at would suggest that one of those, if you had 500 of them, one of them would potentially die just from natural causes. So that means they're dying at a rate of one 500th every year. The mean time to failure is therefore 500 years. Yeah, we know that's not true.
Man, those guys are great. Just the problem is you have to stay 15 the whole time.
But that was in the 1880s, and if you look at, here we go, it gets even better. Like around about 2000, it's down to, oh good lord, was this? This is for all human males, so it gets down to about 2, 3, 4, 7 by 10 to the power of -4. So it's a small number. And
that's kind of in the realm of fit rates.
Yeah, so that if you took a bunch of 15-year-old males, 2000, in the year 2000, I should say, you tested 1,500 of them or so over 1 year, you now expect only one of those males to 1800s.
Yeah.
So it's a 1,500-year lifespan.
Wow. I don't know what I'd do, right? I'd probably not get much anything done.
Well, you're 15 years old.
Well, there's a crisis.
You don't get much done anyway, so
yeah, that's true.
Yeah,
but it's part of any testing is, what are you testing for? Why are you running this test? What are you trying to achieve? Two, I heartily agree with you, Chris, is that if something looks odd or behaves weirdly or signals something's not as expected, that's time to understand it. And if you can show that it's a loose cable on your monitoring device, then that's bad test setup, and you can improve that and drive on. But you now have an understanding of it. If it's truly in your system and it's an intermittent, that's another challenge. That's how do you track that down, and doing the root cause analysis and figuring out what likely things are and how do you measure it matters, and go find it. The other part is that if it's multiple failures over the certain number of cycles, and you want to understand the reliability behavior of that kind of pattern, that's a little bit different statistics than just doing a log normal to it, because you're making the assumption that it's as good as new after every reset. And is it really? And if, depending on the analysis you do, you can uncover patterns that indicate problems, or it's not a problem, or some insights to what's going on. So that approach to statistics also matters in what kinds of things you do. And I think my last thought on it is, if you do all kinds of assessments and you do all kinds of root cause analysis and you have a great understanding of what's going on, and it doesn't matter, you're still going to ship the product independent of whether none of them will work after 10 cycles, you probably working for the wrong company.
There's a couple of bigger picture issues there, but
but it's worth asking the question, and how do I deal with this, and what's the appropriate analysis for it? And I think we added a little bit more to it, things to consider. But if you're running a test right now and you're seeing some anomalies going on it, hopefully because you listen to this podcast and you're brilliant, smart people and conscientious, folks trying to add value, that you're working on it. You're trying to figure out what's going on and make a difference with that. If you're listening to this and you got some other insights that maybe we missed, or I'm sure we missed a few, let us know. We could round out the response to John a bit more clearly, and we appreciate your help with that. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. And Chris and I and the others are available through LinkedIn and our About pages on the Accendo site. So plenty of ways to do it. But and I've got, Chris, just to give you a heads up, I got about 5 or 6 more questions to bounce off of you and the other hosts of the show. So getting into a rhythm now where people are actually asking questions. So I appreciate that. I enjoyed trying to help where we can. All right. So we'll talk to you again soon, Chris. I've got, and I expect a handful more questions from our listeners. That'd be great. All right. Talk to you later.
Balls in their court.
Exactly.
Always a pleasure, Fred.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.